Alrighty, what's up, everyone? My name is Shravan, and Ryan, would you like to quickly introduce yourself real quick?
Yep, I'm Ryan.
All right, and yeah, right now we're going to be teaching our Essence of Backend Engineering APIs workshop on this Wednesday evening. So welcome, everyone. Today we are going to be going over basically what an API is, what a modern, scalable API looks like, and how we can make our own APIs using different programming languages and frameworks. And ultimately, later on in different series, attach databases to those APIs or make those APIs more scalable. So let me start the presentation. So this is part 2 of our series on Essence of Backend Engineering. Like I said, if you didn't make the part 1, which happened last quarter, that's totally fine. We'll have a section where we catch everyone up to speed on what happened there. So to check in to the event on our ACM website, you can use this code. It's the @ P and 1 for API. If you're not familiar with our check-in system, ACM has a membership portal where you can when you attend events, you can check into those events by typing in a code into the website. And by checking in, you earn a certain amount of points. And with those points, you can redeem them to get merchandise on our merchandise store. And we distribute merchandise every Monday at Library Walk. So if you want to pick up any merchandise with those points, you can do so there. It's all free and everything, so it's great. Also, if you do want a link to these slides, I can drop that link really quick. Give me 1 second. Just if you want to follow along. I think it'll be nice to follow along, especially when we get to our interactive portion, because we're going to be doing some coding and going through some hands-on stuff. So it'll be nice to have these slides on hand. Alrighty. So for today's agenda, we're going to briefly talk about a little bit about what we covered in our last Essence of Backend Engineering workshop. That'll be about 10 minutes or so. We're also then going to dive into what an API is. So Ryan's going to explain to us what an API is, how do APIs work, some examples of APIs, and all that kind of stuff. And then we're going to be building our own API from scratch using Node.js. So if you don't already have Node.js installed, feel free to do that right now. I think I linked that in my announcement on the Hack Discord and ACM Discord. But yes, if you don't already have Node.js installed, please install that right now. So we're going to spend roughly 30 to 45 minutes on that section. And then lastly, we're going to be covering API scaling and tips to basically improve the traffic, improve the scalability of our APIs. So let's start with previously on. So the Essence of Backend Engineering series is a multi-quarter series that we started this year. This workshop is the second workshop of that series, covering APIs. Previously, last quarter, we covered an overview of what backend is. So we talked about what is a backend, what's a front end, kind of loosely how the internet works and how software is structured. I'll go over that a little bit in this workshop as well. Next week, we're actually going to be having another workshop on SQL. So that's going to be a more database related workshop that me and Ryan are going to be teaching as well. And then next quarter, we're not sure what weeks yet, but next quarter, we're going to be doing 2 other workshops, one on Docker and one on distributed systems. So more advanced kind of backend workshops. So if you're listening to this one, I highly recommend visiting the ones in spring as well, because you'll learn a lot more about how backend works. So that's going to be exciting. All right, so let's cover a little bit about what we did last workshop. So last workshop, we talked a little bit about what a front end is and what a back end is in the software context. So things that we're going to be looking to in this workshop series is how exactly software is separated between front end and back end components. To give a brief recap, a front end is kind of any system that serves functionality to a user, and a back end is a system that kind of supports the functionality for that front end. So last workshop, we covered the example of a car where like a physical car, where a car's front end is the steering wheel, the brakes, the windshield, the seats. That's all part of the car's front end. Whereas the back end of a car is more of the engine, the axles, anything that kind of keeps the car running so that people can actually drive the car. So like that in software, a software front end is kind of any user interface you're working with, right? So what you're seeing on the screen right now is Google Drive, Google Docs is Google Presentations front end. And then the back end of this system is all the things like Google is storing. Like, for example, it's storing the slides content in some kind of database. And it's storing like my user info in some kind of database as well. And all that kind of stuff. So the backend handles the behind the scenes of all the things that are happening in the front end that's like data related. So next we're asking, what are some technologies used in the software backend? So last workshop, we didn't actually do any hands-on coding. So we didn't get to explore many of those technologies, but this workshop is going to be the first instance of that. We're going to be exploring one main technology, which is Node.js. And I guess another one is Express.js. These are two common technologies you'll see in many backends. In all kinds of projects across like school, if you join clubs and work on software projects, you're likely going to see Node.js and Express somewhere in there. And if you don't know what that is, it's totally no worries. We're going to explain exactly what that is later on. So next, we're going to ask, how do modern software applications structure their backend? We're going to look into how one example, one big company in this workshop structures their API and how we can learn from that. Lastly, we're going to ask ourselves how we can design backends to most efficiently serve data to a front end. And that will be explained in this workshop as well. To cover a little bit about what backend engineering is exactly, basically it's an engineering discipline where we design and build software backends to support business capabilities for a front end. So anything like supporting like a merchandise store for in ACM's case, or supporting the leaderboard, or supporting Amazon.com, like that whole system is what a backend is. And what backend engineers do are building that system and thinking about how we can design a system to be able to reliably and efficiently serve a front end and do so in a secure way as well. All right. After discussing those, we also looked into briefly how the internet works. So to quickly recap on the amount of like knowledge you need about the internet in this series, essentially, we're going to be dealing with like HTTP requests and HTTP responses. So what an HTTP request is it's a protocol or a request that your computer, like your browser, will send to some kind of server in order to ask for some data or ask for some functionality. So the example I provide here is your computer requesting data on Facebook.com. So let's say you log into Facebook.com and your browser needs to get all of like your friends, like the posts, the feed, like all the ads, the recommendations, everything. That's all like not stored on your computer, right? Because if all that was stored on your computer, that would be like a ton of data you need to store. Like all your friends, all your feed, etc. So where that's actually stored is on Facebook's server. So like Facebook or like Meta, the company, has their own databases and servers that host that data. And in order to get that data, you need to do what's called an HTTP request. So what an HTTP request looks like is it starts from your computer, and then it traverses the infrastructure of the internet. So it goes to routers, what's called an ISP, and then it goes to underground cables to another router, ultimately to Facebook.com. For this workshop, you don't really need to know about the infrastructure, but for those of you who are curious, this is what we covered last workshop, briefly like an infrastructure of the internet. Once we make a request, we can ultimately get an HTTP response, which is Facebook basically saying, okay, I have acknowledged your request, I have received your request for data, here's the data. And ultimately that goes back through the infrastructure of the internet and back to the computer. So we will be dealing directly with HTTP request and response in this workshop. We're going to be seeing like how we can process requests and process responses, right? Because what the backend is Facebook's server, right? So like if we were engineers at Facebook, like backend engineers at Facebook, we would be working on Facebook's server. So a lot of the functionality is going to be similar to that. We're going to be dealing with the same problems that Facebook's server is dealing with. Right. That was previously on. Now I'm going to hand it off to Ryan to talk a little bit about APIs. So let me stop sharing and then I'll let Ryan share his screen.
Yep. Let me share my screen real quick.
For sure.
Oh, can you guys see my screen?
Yeah, you're good.
Okay, with the slides, right?
Yeah.
Oh, perfect. So basically, we'll be covering APIs today. And what is an API? And basically, an API stands for Application Programming Interface. You can sort of think of this as a software intermediary / middleman between two different systems that want to communicate with each other, right? And so these function calls are made between applications over HTTP, like Shravan covered, right? And so you can think of an API with an analogy, right? So I'll give the analogy of a waiter, right? So let's say you are a customer that is trying to order food at a restaurant, right? So you go to the restaurant, you have a set of menu items, right? Food that you want to order from this restaurant. And you essentially want to be able to communicate with basically the kitchen, right? So in this analogy, you are the client or the customer, right? And the kitchen / cooks would be the server. To be able to communicate between yourself and the kitchen / cooks, you wouldn't directly go to the kitchen, right? Or order food, right? You would have somewhat of an intermediary / middleman, which is known as the API, right? So basically the API or the waiter in this case would go up to you, right? Take your order, right? So you make that request of, hey, maybe I want 2 slices of pizza or whatever you're ordering, right? The waiter in this case would essentially jot that down, take that information and translate that to the kitchen / cooks, right? The server in this case, right? And once the server and the cooks in the kitchen have finished whatever food you ordered, you're essentially going to get the response back, which is your food, right? So this is just sort of an analogy of how an API is essentially used between different systems to be able to communicate with one another, right? And so a more practical example of this could be maybe like checking weather on your phone, right? So to check weather on your phone, you essentially would go on your phone, right? Open up a mobile application, right? The weather app or something, right? And you would essentially be making an API request to that weather server, right? And by making that request, you might specify, hey, I want to check the weather for this location. Let's say you're in San Diego and you want to find out the weather for the next 7 days in San Diego, right? So you make that API request and that API will essentially communicate to the server, right? Basically extract whatever information and data and retrieve that once it's ready and send it back to you, the client, right? And so once that essentially process finishes, you can see all that information that you requested, right? Another example of this could be sort of like going off that Facebook example that Trevin was covering earlier, where it's like you want to send messages on Facebook, right? To send messages, you would need to make an API call to basically send these messages to Facebook and basically be able to retrieve any messages or data that comes back. Cool. And so this is just like more of a visual representation of sort of the API right here. So you have essentially the customer, which is the app or client in this case, right? The front end, right? You essentially have in the middle, the waiter, the API that communicates between the customer and the kitchen, right? So as you can sort of see right here, there's the whole menu and the customer, which essentially is the client. And from the menu, you can order different types of food. And the API is sort of the connection between you as a client and customer versus the kitchen and the server. Would you like to write and show some code today? Yeah, we'll be covering a live demo basically where Shravan will go through an example. Yep. Okay, so why do we need APIs? It's sort of like something I mentioned earlier in what is APIs, but basically we need to be able to communicate between different devices and front end and back end, right? So to be able to do this, you would essentially need these APIs, right? And also, you can also utilize APIs when you want access to third-party tools, right? So let's say you want to have access to maybe financial data or be able to send payments easily, right? Instead of doing this sort of on your own, you can utilize different third-party tools that already exist, like the Stripe API, or maybe you want to do something with the Google API, right? This essentially allows for you to communicate with these third-party tools.
Cool. Awesome. I want to quickly add one comment here, just to hit the point home. Ryan, can you go back to the last slide real quick?
Yeah, of course. A sec. Yep.
Cool. Yeah, so I like to think of APIs, like Ryan did a great job explaining, but just to hit the home a little harder, basically, right, we have like these two components, there's a front end and a back end. Like the front end is your UI and the back end like holds all the data and like the logic behind the application, right? So an API is very necessary, like to allow the communication, but it also provides a way to restrict like data access to the database that you have, right? So like, let's say we didn't have an API, like let's say like Facebook.com didn't have an API, right? And let's say like the client, like the Facebook.com website, like you can visit, can make direct database calls to Facebook's database, like with no middleman, as Ryan explained. That would be very problematic because like then the Facebook.com website can just get whatever data it wants, right? Like imagine there's things in Facebook's database like other users' accounts, right? Like or like other users' private posts or like other users' private pictures. Those are things that like a browser should not have access to, right? Like you don't want to be able to like look up someone else's like private messages with another person just because that's stored in the same database as your messages. An API allows you to define very specific access patterns to data, which will, if that's kind of unclear right now, we will definitely go into that when we're doing our live coding. And when we have you guys also implement some API routes, you're going to see like we're defining strict access patterns to our data so that like a client can't just directly access like someone else's data. If they are only allowed to request their own data. So like Ryan said in the kitchen analogy, I just can't walk into the kitchen and like take someone else's food. Like that's not allowed. I have to like have the waiter as the middleman to say like, okay, I want my food, and they'll be like, they will validate that, oh, this thing that you listed is your food, I'll get that for you. Like, so that's kind of why APIs are important.
Yep, definitely. Thanks for adding on. Cool. So we'll move on to the next slide, which is HTTP status codes. And these are essentially different status codes when the specific HTTP request has been made. And essentially the server will basically give a code depending on the response, right? And so these different codes can be grouped into 5 different classes, right? So if you make a call to the server and the server returns a response, right, with a status code that ranges between 100 to 199, that will essentially be an informational response, right? Next thing will be basically what you want to look for a response is somewhere in the 200 to 299 range, which would indicate that whatever request that you made from the API, right, would be successful. Another important one would be from range 400 to 499, which are client error responses, right? So this essentially are basically responses that you get back from the server that indicate that your request has not been successfully made and you're not getting that response back. So some common examples of client error responses could be like, a common one, right? Like 404. I'm sure like most people have at least witnessed that once, where it's like basically the URL that you're essentially requesting is not been found, right? And lastly, the last category I want to cover is between the range of 500 to 599, which are basically server error responses, right? So this could sort of come up, the status code can be returned when you have an issue with the server, right? So not really from a client perspective, but more from a backend perspective, where maybe there's like a server outage or server crash or something like that, right? Where you essentially aren't able to successfully make that request. Okay, so in HTTP, there's a set of methods and sort of restrictions for what types of methods and requests that you can be making, right? So I'll just break on the general categories for the different types of HTTP methods, but I'm sure there's more out there as well, right? So one of the common patterns, or I guess methods for HTTP would be the GET request, right? And so basically what a GET request does is essentially goes to the server, right? And basically tries to retrieve data, right? So this is essentially like going to like a waiter, right? So in the restaurant analogy where it's like you're requesting a specific item from the menu, right? So the waiter will essentially go to the kitchen, retrieve that food, and you're basically able to get that food back, right? What you ordered, right? So that's essentially a GET request. And to, I guess, sort of clarify this a little bit, it's sort of like in the user database, right? So let's say you have maybe like a public user database, right? And you want to be able to retrieve all the user information in the database, right? So by making a GET request, you essentially retrieve all the data that's sort of, in the server regarding users, right? And the next type of request that I want to sort of cover would be the POST request, which is essentially used to basically send information to the server, right? So there's more of like an addition kind of thing, right? And so this, I can sort of explain this further with the user database again, where let's say you want to be able to create a new user, right? So this could be a case where you register a new account, right? And basically what you're doing is essentially you have this new user information, right? That can consist of maybe like a name, email, password, and you want to be able to basically add this new information to the server, right? In this case, you wouldn't be retrieving any data, right? You'd be actually directly sending that new data over to modify that database to essentially add information to that server, right? And so that's where essentially the post request would come in. Next type of request that I'm going to cover would be the put request. So basically this comes up when you have a database and you have existing resources and different that's information that already exists in the database that you want to modify, right? So going off the user database, you might have a user that's already in there, but maybe when they're signing up, they made a mistake. When they're registering their account, maybe they have the wrong first name or last name, and they want to essentially be able to modify that, right? So that information already is in the database, right? But by making a pull request, you'd be able to essentially modify maybe like the first name or the last name. Okay, and then lastly, the type of method I want to cover would be the deletes method, right? And this is essentially the case of where you have information in the database that you essentially want to remove for whatever reason, right? So let's say there's maybe a user that wants to permanently delete their account, right? Or something like that, where you want to essentially delete that information from the database. And that's where the delete request would come in. And I think, yeah, basically I'll be able to show you guys essentially how all of this would work sort of in like a real life example. And this could be through the Twitter API, which is a pretty popular API to be able to show this stuff. Let me pull it up. Cool. So basically the Twitter API is essentially a way for you to communicate to like a third-party tool, right? So maybe like Twitter, and you want to essentially maybe get some tweets of your own, right? So normally, I believe you need to get authentication code to be able to actually access this. But I just wanted to quickly show you guys some of the documentation to show you guys the different types of methods that we can have, right? So in this case, you have the tweets lookup, where maybe you want to look up a specific tweet, like an ID or a set of tweets that you want to essentially extract from Twitter, right? And so basically, this is an API call where you would essentially be making this call to api.twitter.com. And this is essentially a GET request, right? GET request because, like it says here, it says it returns a variety of information about the tweet specified by the requested ID or list of IDs, right? So let's say you have, I don't know, maybe a tweet from Biden that you essentially want to retrieve information from, right? So you would essentially get that ID of that tweet, right? And basically make that API call, right, to that specific endpoint to retrieve information regarding that, right? And there's different parameters that can be inserted into this, where you have maybe an ID, right, which is required because you need to be able to retrieve information for that specific tweet. And this is once again a GET request because you're retrieving information / data instead of basically sending something over, adding it, right? And there's optional fields like media fields, place fields, etc., that essentially can be tied to that API request to basically get different types of data. And yeah, so this is essentially just what an example request would sort of look like for a GET. And this is essentially what sample response that you might be getting back from the server, right? So you might have the ID and maybe the text of that tweet, and maybe another ID for that tweet as well. So that's just an example of a GET request that can be sort of applied using the Twitter API. Let me check the chat real quick. Shravan, are you good with the chat or?
Yeah, I got it.
Okay, cool. Okay, the next set of I guess API calls that I want to show you guys would be the post request. So this is sort of like what I covered in the slides earlier, where you're essentially going to be adding something to the database, right? So you're essentially making a request where you're essentially adding new information to the server, right? And so basically this post request in this case would be creating a tweet on the behalf of an authenticated user, right? So maybe you want to create a tweet or post something, right? And to essentially be able to do that, you would have to make a post request, right? Because you're essentially adding new information to the database, which would be a tweet in this case, right? So this is essentially the URL. I believe there's a set of parameters, once again, that you can essentially add, right? So this could be stuff like for super followers only. Maybe you want to restrict this to a specific geolocation, etc. And there's these different parameters that you can add to that request to be able to customize it, basically. And this is essentially what a request would look like. Once again, a post request. And once the server essentially has a status code of 200, for example, and has something that's successful, that means that essentially you'd get a response back where maybe you want to have basically the data that you essentially insert, right? Which would be a tweet of maybe you tweeted hello world and you want to insert that into the Twitter server.
Cool. I'll add a quick comment here. Hopefully y'all are kind of getting the idea of what we meant earlier by like restricting data access to specific things. So like here you can see we can't like directly just look up Twitter's database and get any tweet we want, right? We are restricted to accessing this API, which guards the database as like a middleman. And we're restricted to like specific calls like get tweets, post tweets, put tweets, delete tweets, right? And like Brian's going over here, there's a lot of rules that each API route kind of defines, right? Like I can't get like every tweet that exists on Twitter, right? I can get like a specific tweet, or like I can't create a tweet from someone else's account, right? Like if you think like if I had direct database access, like let's say there's like a spreadsheet or like a database table that stores all the tweets, I can't just like insert my own tweet and like change the author to be someone else. Like I have to create a tweet from myself, and like the API restricts that to be like only be able to create that by myself. So that's why APIs are so important, like because Twitter defines a set of data structure, like not data structures, like a set of like functionality that anyone can use to access Twitter's data. So like twitter.com uses this API for sure. Like twitter.com, like if you imagine their front end is like HTML, CSS, JavaScript, they're going to be making API calls to this API. And we'll go over what an API call is in our live coding session, because that might be unclear right now. Like, how do I actually like make an API request? How do I request data? All that kind of stuff. We'll go over that like in a sec. But yeah, like Twitter API allows us to like have specific a set of functionality that we can't just like access the database for.
Cool. Yeah, thanks for adding that, Shravan. Okay, and the last sort of method that I want to cover with this Twitter API would be the deletes. And essentially, it allows for a user or an authenticated user to delete a tweet, right? And so like Shravan mentioned that earlier, for the purpose of an API, essentially serving as a middleman, you don't want to just be able to have the power, right, in terms of the Twitter server to be able to delete anyone's post, right? Because that wouldn't be good. So essentially, APIs essentially serving as a guardman to essentially prevent that kind of stuff, right? And to only be able to delete tweets that you actually have access to, right? Which would probably be your own, right? And so, yeah, this is just another example of deletes where you would be passing in an ID, right? The tweet ID that you want to delete. And basically this is essentially what a response that has succeeded would return. Cool. I think that should be it for the Twitter API example. You guys have any questions? Feel free to just unmute yourself or type in chat. Okay, cool. No one has any questions. I'll move on for now. So essentially, we've covered the basics of APIs and sort of why they're necessary. And we'll be covering a bit more advanced topics, but that's still necessary for backend programming. So one of these concepts is authentication, right? So it's basically the process of verifying the identity of a user or device, right? And so like Shravan mentioned, you don't want to have the ability for any user to directly access the server and basically have any data that they want from that server or be able to modify it, et cetera, right? Or delete, right? And so that's why an API essentially is there to basically be the guardman / middleman to only allow for access to things you actually do have access to, right? And so this is essentially where authentication comes in, where you want to, whenever you're making a request, the server wants to verify that identity, right? To make sure that whatever request you're making, you actually are authorized to be able to do, right? And so one of these common methods for authentication would be using the bearer authentication method, right? And this is essentially an HTTP authentication scheme that involves basically security tokens called bearer tokens that are essentially generated when a user is basically created or signed up. And this is essentially a token that's unique to that user, right? And so when a client or I guess user sends tokens through, like makes the request, that essentially token will be attached to that request. So the server will essentially know, like, hey, it's this this user essentially is making a request through this token, right? And depending on the access rights of that token, you'll be able to have access to different parts of things, right? Different parts of the data, right? And so this is essentially how a server will give access to different authentication levels depending on the user, I guess. Cool. And then the next topic I want to cover is rate limiting. And so basically what this is essentially the maximum number of calls you want to allow in a particular time interval, right? And so basically what this means is you want to, if there needs to be a need, to basically limit the number of calls you can make, right? An API call, right? So for example, let's say you have a very small server, right, of maybe user databases or something like that, right? Where you have a small server and you don't want the API calls to essentially exceed a certain limit, as that can lead to problematic issues with the server, such as it crashing, right? And so there's different types of ways that you can actually go about limiting the number of calls, right? So there's two types where you have the hard rate limit, which is essentially when you're trying to make the call, it's basically a hard limit where it's like, if you make the call and it sees that the limit has been exceeded, the call will essentially be aborted and an error is returned, right? And this is in contrast to a soft rate limit where basically it still allows the call to complete. It allows the request to be made and the response to be returned, but it actually provides a warning message. So you can still go over, but it's still basically, you'll have a warning. And this is essentially allows for a bit more scalability in the sense that there won't be unexpected server crashes, and you can sort of predefine a number of calls that you essentially want to allow in a particular time interval. Cool. I think that should be it for covering the concepts of APIs. And so I'll turn it over to Shravan real quick where he'll essentially be going over how to build their own API with like a live demo. So I'll stop screen sharing and it should be good.
Sweet. Thanks, Ryan. Appreciate the explanations. Alrighty, it's time to get our hands dirty with building our own API. Let me share my screen again. Cool. Everyone can see. Are we good? I think we should be good. I'm going to assume we're good. All right. So let's build our own API now. So we're going to be working with, in this workshop, an auction house system. So this is going to be a system that we're going to be creating an API for. And the basic idea, or I guess the basic plan, is for this workshop, we're going to be implementing an auction house API. Next workshop, we'll be implementing the database for it. And in the future, we might make a distributed load balanced auction system. We'll see. Okay, so what is an auction house? What are the requirements? Okay, so for those of you who might not be familiar with like what an auction is or what an auction house is, basically, an auction is like the selling of an item where users can like bid on the price of the item, and ultimately like the bid can go up and up till ultimately no one else wants to pay a higher price, or ultimately when the auction ends, in which case the highest bidder will get the item. So for our auction house requirements, we have 4 main requirements right here. The first one is that users can create auctions for items that they want to sell. So essentially, like, let's say I want, like I have like a water bottle, or like in real life, maybe I have like jewelry, or I have like a championship ring that I want to sell for a high amount of money. I can create an auction and people can start bidding to that auction. So that's requirement number 2. Users can bid on auctions for items that they want to buy. For number 3, auctions will last a certain duration of time, after which the auction will terminate and the highest bidder gets the item. So like whoever has bid the highest amount of money for the item will get the item after the auction's done. And then lastly, users must bid a certain amount higher than the highest bid. Okay, what does that mean? So like, let's say I bid $10 for an item. the person next to me can't just bid $10 and 1 cent. Like they can't just like keep like inching up the bid. Our API should be able to handle like a minimum increment essentially, where let's say like I define that the minimum increment for an auction is like $5. So let's say if I bid $10 on the auction, the next person has to bid at least 15. They could bid higher, but they could bid at least 15. It can't just be like $10 and 1 cent. So the goal in this workshop is to implement an API that supports this functionality. So we're worrying about just the backend for a system like this. We don't have a front end we're working with. So you can imagine like an auction house front end would be something like, there'd be like form inputs for like creating an auction. Like you can create like a name, like a duration, etc. We don't have that. We're going to be working directly with the backend, but we'll see how we can actually like create an API and make requests back to that API using get post requests to create auctions, create bids, etc. So that's the game plan. So in that being said, our question is, how do we take this list of requirements and convert it into an API specification, right? Like how do we make an API, define an API routes, which like Ryan showed in the Twitter demo, are like get/tweets, get post/tweet, like those are all API routes. How can we convert this specification into a list of API routes? Does anyone want to take a shot at like maybe some kind of API route that we want to define to satisfy some of these requirements? So like an example of a route might be like post and then /merchandise, like for our ACM store, right? Like if we want to be able to create merchandise, an API route for that would be like post/merchandise, like that would create merchandise, and we can define exactly what we're doing in that route. But does anyone have any initial guesses? I realize I can't see the chat, so I will pop open the chat. Yeah, any guesses on that? If not, no worries. We'll go into exactly what routes we need. But cool. We have get/auctions to get a list of current auctions. Yeah, that's totally a route we can implement. Basically, like Steven defined, he like said the HTTP method, the route name, and then what it does. That's exactly right. If we want to see all the auctions that are ongoing, we can have a get/auctions route that will return data in our database of all the auctions that are running, or all the auctions that like ever exist, right? Like any other guesses? So we can see like here in our API design, our first route would be get auctions. I guess another thing we can have is getting a specific auction. So like, let's say I want to search for a specific auction, or I want to view like all the data for a specific auction. I can have a get/auction/ID route. So the ID you see here is something called a query parameter, which we'll explore in our coding. But basically, think of it like an API route as a function and the query parameter as a parameter to that function. So I can like get a specific auction by like passing in the ID as a parameter. We saw a very similar case in the Twitter API, like for like getting a specific tweet. Also, we have post/auction, right? So we can like, so that we can create an auction. So that's another route we would need. And then arguably one of the more important routes that we need is placing a bid. So what is this route? This route is post/auction/ID/bid. So what this route is saying is we can bid on a specific auction, right? So I'm going to define a route that will take in an auction ID, and then it's going to be, the name has /bid appended to it to define that, okay, we are placing a bid on this auction. So when we make a HTTP request to this auction, we're going to have to pass in our bidding information, essentially. And that's going to be how ultimately like the bidding all works. And then lastly, we can have a route for creating users, so that we have like user information about like how much money they have, or who the user is, like their username. And that person will be tied to like whoever is auctioning the item, the auctioneer, and also whoever is placing bids, the bidder, right? So these two will both have users in them. Cool. Any questions on this initial API design? We're going to have this API. We're not going to have a route for items. You might think we might need a route for items. We could, but I think that'll add a little too much complexity to this system right now. But for now, we're going to have routes for creating auctions, creating bids, and creating users, and then as well as getting auctions. Cool. Let us go into an API demo. So for our auction system, we have a GitHub repository that has starter code for this auction system. And we're going to be diving into exactly what that starter code holds. So let me copy this into the chat, and we will get the system set up on everyone's computer, and we'll go from there. So in order to get the code onto your local computer, we're going to do what's called forking the repository. So if we visit this repository, let me close the meeting controls. If we go to the repository, you should be on this screen. This is what everyone should see. What you can do is click this fork button. And by forking this, essentially you will have the code as a repository on your GitHub account. If you don't already have a GitHub account, you can create one right now. And you can like use whatever email you want. I think if you use your student email, you get like GitHub student pack or something like that, where you get a bunch of free stuff, which is awesome. But that'll be the first step. So when you're on this page with the link I just sent, go ahead and click fork. I can't fork it because it's to my own account. Like it's telling me to fork to another repository, but when you click this, you should be able to fork it to your own account. So once that's done, what we're going to do is I can demo this on this page. If you're still forking, that's totally fine. But what we can do is then clone this repository to our computer. So what you can do is click this code button on your forked repository. I'm doing this on my repository. And then you can copy this URL. You can do it with 3 different ways. I'm going to use HTTPS because that's just how I have it set up. You can copy this link, and then you can go to a terminal that you have open. So if you're a Windows user, you can use command prompt or Microsoft PowerShell. So like those of you who might be in like CSE 15L, like I think they teach what a terminal is there. So that's exactly what we're going to be using. If you're on Mac, I think the app is called Terminal. You can open that. And then what you're going to do is you can do Git. You should have Git installed on the terminal. I think Windows might not have it by default, but I'm pretty sure Mac does. So if you don't have Git installed, you can visit like Git install or Git install. Right. You can download it here. I'll drop the link in case anyone doesn't have Git. Follow this instruction. But what we're going to do is clone this repository locally. So I can do git clone and then paste. That is the wrong link. Git clone. Let me copy this link again. Paste. And then that will clone the auction system to wherever you are right now. So for me, that shows up here. I'm going to go into my projects directory because I cloned it there. So for those of you who know Linux, you can use cd projects auction system. I think cd is the command on Windows as well. For if you're using the command prompt, like if you're going to use command prompt, like you could do like L or like dir and then like cd documents or something like that, or Docker. That's fine. Is Windows PowerShell good enough? Yeah, Windows PowerShell is totally fine. Just wherever you, whatever terminal you need, you can use. We aren't using like PowerShell or like WSL specific things, but if you would like to use WSL, if you know what WSL is, feel free to use it. I always recommend WSL. I'm using WSL2 right now. So this is like a Linux system on Windows. For those of you who don't know what WSL is, it's basically Windows subsystem for Linux. So you can have like a Linux distribution on your Windows computer. So I'm rocking Ubuntu right now. Cool. So once you git clone the repository, you can type cd and then the repository name to get into it. So I'm in my repository right now. If you type ls, then you should see these packages. You might not see node modules. That's totally fine. I'll actually, I won't delete that here, but like you should see basically a bunch of source files. Like these two files are going to be the most important ones, as well as types. And then that'll be that. Cool. I'll give like 30 seconds for everyone to catch up. If anyone has any questions on the setup, let me know. But once you're seeded into the directory, you should be good. And then we'll continue like in a sec. Any reason we're using TypeScript specifically for this demo? Yeah, I'm using TypeScript because we can have types for our HTTP requests and responses, just so it's easier to understand the models that are going on. If you don't know TypeScript, that's totally fine. I'll like kind of explain how TypeScript works here. TypeScript is basically a, I think, superset of JavaScript. So if you know JavaScript, that's totally fine. But yeah, I use TypeScript here so that we can look at types for our auctions, bids, and users. Cool. I'm going to assume everyone who wants to follow along is good here. So what we can do is open up this directory in our code editor, whatever editor we want to use. I use VS Code. So in VS Code, what you could do is go to like file, open folder, like file, open folder, and then like find it. I already have it open. Alternatively, if you're on Linux and you have the code command, you can run code period in the directory, and that'll open it up here. I just opened up a different directory. Let me close that. But yeah, whatever editor you want to use, I just use VS Code. But yeah, any editor is fine. All right. Let's see. So right now, everyone should have these files on their VS Code or on whatever editor you're using. So you won't necessarily have a package.lock.json or a node modules. We're gonna explain how we can get those files in a sec. But if everyone has these files, then you're caught up. Like this is what we're gonna be working with. Cool. All right, so let's run one quick command so that we can get these two files, the package lock and node modules files. Like I said in the beginning of the workshop, we're going to be using Node.js in this series. So if you run node-v, that should output a version. It doesn't have to be this exact version, I think. But you should have Node.js installed. If you don't have it installed, I can quickly pull up the Node.js link, but you're going to be downloading it right here. And if you don't have it in a specific terminal, you might need to install it for that specific terminal. But if you can run node-v and npm-v, then your setup is fine. npm is a package manager for Node, so that's how we install packages like Typescript and like Express.js. And Express.js we're going to see is used for actually creating an API, right? So this file may look very daunting. Don't worry, you'll never have to look at this file ever. It's just a list of dependencies for the project. Do not worry about that file. Okay, so let's dive into what the code actually does. I'll start with the simplest part, which is the types file. So in TypeScript, first of all, TypeScript is a programming language. It is basically JavaScript, but with types and with other features like object-oriented programming, inheritance, all that kind of stuff. So like, I like to think of it like a mix of JavaScript and Java. So we can define types in TypeScript. A type is in programming is basically like it's what form like a specific variable takes, right? So if you've done Java, like string, int, like all that stuff, those are all types. So we can define custom types in TypeScript for specific use cases that we have. So I defined 3 types here, and we'll go over exactly what these types are. The first one is called auction. So we're going to have variables in our code that store auction data, right? So when we write code, we're going to be dealing directly with auctions, bids, and users. So here we defined a type where the type contains the following fields. So you can think of this like a class in Java with instance variables. This is very similar to that. There's a question, where will the recording be posted? We're going to be posting it on our ACM YouTube. So on YouTube, you can look up ACM UCSD, or you can also visit acmurl.com/YouTube. And the recording should be up in a few days if you can't make this entire like workshop. Cool. So this is going to be our auction type. So every auction will have an ID to uniquely identify that auction. They're also going to have an auctioneer. So that's going to be the user who created the auction. And I'll briefly explain why is this a string. So the reason this is a string is it'll reference the ID variable for user. So this is kind of like a database concept, but essentially in more complicated software systems, we have data that is related to one another, right? So if you think about it, every auction is made by a user and every bid is placed by a user, right? So there's kind of relationships involved where a user is tied to an auction. They're also tied to a bid is tied to an auction. So every time we have something like a string here that refers to another type, that's what's happening. So in an auction variable, we would have like auctioneer might be the ID of a user, right? Similar to a bid's auction would be the ID of an auction right here. So that's kind of how that works. All right, then we have a name. All right, so every auction will have a name. We'll also have a description. It'll have a start and end time, and these types are going to be of type date. So like JavaScript has a date type, and those are going to be, that's going to store the exact date and time that we're going to be working with. Every auction also has a starting bid, so you can't just start the bid at 0. So like let's say if I'm selling like if I'm auctioning off like jewelry, for example, maybe I want the starting bid to be like $20,000. And then the min increment is the thing I explained earlier. It's the minimum difference between the highest existing bid and an incoming bid. So if my min increment is 5,000, then I have to place a minimum of 25,000 on the jewelry. I can't just bid $20,001 or like 21 or like 20,100, for example. So that's the auction type. We also have the bid type. So every bid has its own unique identifier, so we can look up a bid. I'll explain what that means when we go through our other code. We also have an auction, right? So every bid has an auction that it's linked to. Every bid also has a bidder, which is the user it's linked to. And every bid also has an amount, right? So like the amount of money you're placing. Lastly, we have the user with the unique identifier, a username, and the balance. And the unique identifier is we're going to be using what's called a UUID, a universally unique identifier, and that's just gonna be like a jumble of characters and numbers that theoretically can never exist. Like of the same type can never exist in the universe because it's like 2 to the 62% chance like that you can land that UUID. So that's why it's like uniquely identifies the user. It's not necessarily the username of the user, like the username is something separate. So that's what that is. Any questions on these types? If you're not familiar with the syntax of like export type equals bid, that's totally fine. Okay, we have a question. Why is there a question mark next to the ID variable? Great question. What this means is that the ID property is optional. So what that means is, let's say I want to create a variable of type auction that variable does not need to have the ID property with it. Well, and why is that the case? I guess is the question. The reason we have that is because when we create an auction via an API request, that auction doesn't have an ID, right? Like it'll only have an ID once our server processes it. So when we go to Postman and display and like create an auction, the auction will have every field except ID, right? Like because we're not in charge of generating that ID. It's something that the backend is in charge of doing. So like me as a client, I don't have to worry about the ID, but the backend will create an ID and it'll be stored as such. So the question mark is like optional fields in TypeScript. Good question. Any other questions about, I guess, the premise or like specific syntax, anything? Okay, cool. Let us go to controllers.ts now. Okay, let's go to controllers.ts. So there's a lot of code happening here, and I'll walk line by line to explain what everything's happening. So essentially, like I said before, Express is a web application framework that Node.js uses in order to create API routes for people to use. So we've seen in previous examples, right? Like Twitter has their own API. This is actually how you define an API. So like how you create a route and like have some code that runs when that route is called. That is what Express handles. So we can import Express from Express. That just all that means is we're importing the package so that we can use it in our code. Here we're importing the Uuid package. We have this specific syntax as like star as Uuid, just because the way Uuid is exported in its package. But basically, this will allow us to randomly generate Uuids as our ID. Lastly, we're importing our 3 types from the types file right here to use in our code. So that's that. That's what we're going to be importing. This line of code essentially is like boilerplate, what's called boilerplate. It's just how the project is set up, and it's not like something you need to be too worried about. You're never going to change this line of code or remove it. It's always going to be there. But what's happening here is there is a router variable that we can basically use to create APIs. So this is the syntax. This is not something you have to memorize. I looked this up when I created this code. It's totally fine not having to memorize it. It's just a specific detail. So you can see line 5, we use the router. Down here, we use router.get/auctions to create a API route that has a get request, and that's called /auctions. So like Steven mentioned earlier, we want a /auctions route. This is the syntax to create that. Here we have our database. So for this workshop, we're not going to have an actual database. We have 3 maps, like hash maps here. If you've like taken CSE12 and know what a hash map is, this is essentially a hash map. It's like a key value data structure where you can look up specific data by its key. So here we have 3 maps for auctions, bids, and users, where you can look up an auction, a bid, and a user by its ID. So that's why it's string to auction. Essentially, you can have a mapping like you see here. We have a mapping from auctioneer ID to auctioneer. Right, so auctioneer ID is a string. The auctioneer, I should add the type here, is a user, right? And we're going to set auctioneer ID to auction. Like this is going to set the map, like a key value pair. All right, so what's happening here then? Here, we're creating a fake auctioneer as like a sample user that always exists in our API. And the reason we have this is so that we can create a first auction without having like any users. I'll explain what that means when we're doing the APIs part, but this defines like a mock user as like some auctioneers so that we don't always have to create a new user to create an auction. because when we're testing our API, we're gonna have to create users, create options, create bids. It's gonna be a lot of work, so we don't want to have to like keep creating different users for creating auctions and creating bids. So here you can see this is the syntax for creating an object. You have const auctioneer, and then this is the this is the syntax for defining its type. So this is of type user, and you can see it has an ID of auctioneer ID. So I hard coded this auctioneer ID, and you'll see exactly why we do that in Postman. So don't worry if you're confused right now. We have the username as auctioneer and the balance is 100. So this will be an auctioneer that we use in our API requests. And then this will just add it to our database. Okay, let us get into our routes now. Finally, we're getting into the API stuff. Okay, so here I've defined 2 routes that have already been implemented, and then down here we have 3 routes that we're going to implement. So like we explained in our concept theory, like the concept part of our workshop, these are 5 API routes. You can see in our router object, we have like router.get, right? Router.post, router.put, router.delete. We have all these methods to create API routes. So here we create an API route called auctions. So that's provided by this string. And then we have this kind of chunk of code happening here. So what is this exactly? This right here is called is a function in JavaScript essentially. So I think it's called an anonymous function because the function has no name. But in JavaScript normally you can define functions like function, test function, and then have like int1, int2. Right? That's something you can do in JavaScript. That's how you define a function, right? In Java, it's like public void test function, right? That's how you define a function. This syntax is a way to like create functions ourselves. But if you want to pass in a function into another function, which is what's happening here, you can use this syntax. So this is just the parameters of a function, and it's not like named or anything. So if this is also confusing, don't worry too much. This is like what Express does to allow you to work with requests and responses. But here you can see what is passed in. Right now we have a rec object, which is of type request, and we have a response object of type response. Don't worry about this like generics happening here. That's like a minor detail. But essentially, this allows us to work with requests and responses within our code, right? So remember, an API will take in an HTTP request and return a response, right? We are implementing the waiter right here in our analogy. We should be able to take in a request, get its data, work with the data, and then return a response to the client. So here, this route is a route that gets all the auctions that currently exist in our database. So in this API route, what we do is this is like some JavaScript that's happening here. Essentially, we have our auction list, and you can see it's of type auction array, right? You can see the type here because we're using Typescript. It is an array from the auctions map values. So don't worry if you're not familiar with the syntax, but yeah, this is how you get. We're basically converting the map's values into an array. So this is how you get all the auctions. And then this line is an important line. We are using the response object and setting the status code of the response, and then returning a JSON of the auctions. Okay, so let's dissect this a little bit. Right now, like we said, in this function that we pass in, that Express defines the types for, right? We didn't define the types for this. We have a res object. So right in our res object, you can see we can do a lot of things like redirect, render, and like add listener, like a bunch of stuff. If we do status, right, we could set the status code, which Brian explained, like 200, 404, 500, all that stuff, of our response. And then we could pass in our response data back to the client. So what this does is it sends a JSON response, which is a it stands for JavaScript object notation, and it's essentially a structured way of sending data back to a client. So here we are returning a JSON that consists of the key auctions and the value auction list. So JSON is like a hash map where it's like key values. So that's kind of what the auctions are returning, like what this route is returning. Okay, so we talked a lot about API routes and how they're defined. How do we actually call these API routes? So what we're going to do is answer that question by running our code. Okay, so before we run our code, what we're going to need to do is install all the dependencies in our project, right? So we have Node modules, which has a ton of dependencies, and package.json. This is how our code is going to operate because we have we're importing from Express, from Uuid, etc. We're using Typescript, all that. So what we can do is in our directory, let's run npm install. So that took like half a second for me because I already had everything installed, but this will take some time because you need to install Typescript, install Express, install Uuid, etc. So let's take like a minute and kind of make sure everyone has that installed before we continue. And if there's any questions, let me know. If anyone runs into any errors, me or Ryan can help you out with that. Okay, cool. I'm gonna proceed with the demo. If it's not installed, finish installing it, that's fine, because I'm gonna demo something for a couple of minutes. So after we install everything, then what we can do is actually run our code. So if we look at package.json, this defines how we can operate with our Node.js code that exists in this file. I wouldn't worry too much about what's in this file. This essentially starts up a server, like an API that we can use. This I literally just copied and pasted from the internet. There's you do not need to know exactly what each thing does. I know that sounds kind of weird, I'm saying you don't need to know all of your code base. But for a lot of things that need a lot of setup, I think that's a fine thing to do, because you're never actually gonna you're gonna very rarely add to this file, right? This is a file that is simply there to set up the server, whereas a lot of the code you would be adding is in the actual logic of the application. So what we can do is type in npm run dev, right? That'll run the dev script of our code, and the dev script you can see in package log scripts dev right here. This is basically a command that you don't need to know too much about this, but basically all it does is it takes our TypeScript code and compiles it on the fly and runs it. And then anytime you update the file, it'll restart the server, and so that your changes are automatically there. This is using a package called nodemon, nodemon. I'm not too sure how it's pronounced, but it's using nodemon. And then we use ts-node to compile the TypeScript. Because TypeScript is a compiled language, actually. JavaScript is an interpreted language, which means that there's no compiler. But JavaScript or TypeScript is compiled because it has types and everything. So if everything works, then you should see this message: server started on port 3000. What does that mean? Well, this means that the server is now accessible to us on port 3000. So what that means is we can actually just go to our browser and we could type in localhost :3000. So that should basically it means that like the code is being hosted locally and on port 3000. So that's how we define what that is. So if everything works so far, we should see this message, cannot get slash. Okay, what the hell is this message? Why is our screen all erroring out and not getting anything? Well, if you remember, we haven't actually defined an API route for just slash, right? So you can see we have one for slash auction, everything, slash user. But we don't actually have one for get. So that's why we actually don't see anything in the get slash. But if what we do is type in localhost 3000 slash auctions, then here we see something a little more interesting. You can see we have a JSON response with auctions : empty array. And what this is basically showing us is all the auctions that are stored in our database, which is none, right? Because we haven't actually added any auction. So this is in JSON format. I have a JSON prettier extension, JSON formatter. If I go to raw, like this is probably what you see. But if you want to install this extension, it's called JSON formatter. So that's what that is. Cool. So alternatively, we can also type in like access like another route, right? Like get auction slash ID. Right? Like maybe I type in auction slash like hello world. Here you can see we get an error that says auction hello world not found, right? Because there's no auctions at all, and there's definitely no auction with an ID of hello world. And that directly responds to this code right here, which is you can see here we get the ID from parameters. This is JavaScript shorthand, which is equivalent to const ID equals rect.params.id. Here, like you see, we refer to ID twice. Instead, what we can do in JavaScript is destructure this object so we get ID here. But these two lines do the same thing. So what we have here is our ID, and then we can get our auction from our database. And then if it does exist, we return it. Otherwise, we return a 404 saying we didn't find it. And that's what that code does. Any questions on these two API routes? And if we think about how these API routes are accessed from our front end, like let's say we have an auction house front end, the front end will have code that calls this URL, right? So like if the front end wants some data from our server, it will have to access the data with this URL, get the data, and then parse it. So the front end, like a front end, will have its own code that makes an HTTP request and responds to the HTTP response from the server. What we as backend developers are in charge of is taking an HTTP request from a client, doing something with it, and returning a response. Cool. So is everyone like at this point is like did anyone have any like issues they ran into like getting up to this point? Because we're going to start doing some coding. I think if everyone who wants to like participate in this like interactive session like is up to this point, then we should be good to continue. How did you get it hosted again? What I did in my terminal is here, I can close this with Control-C. I could type in npm install first, right? So make sure I install all my dependencies, and I can run npm run dev, and this will automatically host the server on localhost. And the way that's done is via this index.js, like this line of code, a server.listen port 3000, and then it just console.logs once this is done. And if anyone has a setup questions that they need one-on-one help with, me and Ryan are going to hop on Discord once we do our interactive session where you can ask us directly. So I'm going to continue on. Cool. Where am I at? Okay. So again, if you want the instructions on the screen, that's right here. You can refer to this slide if there's any setup issues. But this is what we did in our code. So together, let us implement these two functions. So I'm going to go over how these functions we can implement, and then together, or like as an exercise, you all are going to be implementing the bid creation route. So that's going to be the game plan for this interactive session. Okay, cool. So how should we implement post/auction and post/user? Let's do that right now. So I can exit, close this, and then I'll go here. Okay, so here is our to-do to implement auction. And with a post request, the way a post request is, remember, it's a request where the client sends data to the server, and the server processes the data and stores it in our database and then returns it to the client, right? So that's going to be our job here. The client will provide some kind of data to the server, and we're going to be processing that data. And I guess before we get into that, let's explain how do we actually send data to our API, right? Like, because it might be a little confusing, like in our browser, like in this, we weren't really sending any data, right? Like we were just like entering a URL, and that made the GET request to our API. So it turns out the browser is only capable of making GET requests like in our URL. So if I go to like google.com, right, or like I go like yahoo.com, what's happening is a GET request is sent to yahoo.com to get all the HTML and everything. So likewise, a GET request is sent to our API here. So we can't actually make a post request. The way we make post requests is using Postman. So I linked in my announcement for everyone to like download Postman. If you want to participate, you should have this application downloaded on your computer. If you don't, that's fine. There's actually a web version of Postman. If you go to postman.com, there's actually like there should be like a web kind of interface that you can work with. You can see here, like if you have an account, you might need to create an account, but that should be like pretty simple. You can actually like straight up start using Postman here. So let me explain what Postman is. So here I have what's called a Postman Collection, which is a bunch of requests that I can send to our API. So here I have the same URL that I showed earlier, right? Except it's with post auction, and I can actually specify what method to use. So what you all are going to do is actually import this collection so that you also have it as well. So like here I have another request called get all auctions, and I can send this, and I have my auctions here, right? Same exact thing I saw in my UI, right? So what we're going to do now is everyone can open up Postman right now, and we're actually going to import this collection before we implement any routes yet. So if I hop over to this slide, I sent a file that's in our hack Discord that has the a JSON version of all this stuff that you're going to import. So I can actually pull up hack Discord right here, but essentially, if you're not in the hack Discord, I believe the URL to join is acmurl.com/hack-discord. /hack-discord. You can join that Discord, and then in the workshops chat, I have a auction API Postman collection for Essence of Backend workshop. So what you all can do is once you have Postman open, we're going to download this file right here. So you can click download. This will download a JSON file, and we won't do anything with it yet. We're just going to download it right now. Let me know if anyone has issues downloading this. But essentially, what we're doing right now is importing this exact thing you see here. Cool. I'm going to assume everyone's good. So what we're going to do now is on Postman, what we can do is go to File and then Import. And then here you can see we can import by upload files. So we're going to click that. And then what we can do is click on our what we just downloaded. So I have this in a different directory, but whatever you just downloaded, we can have right here, or we can import right here. So you're going to click on that file and then click open. And then you should see something like this. Once we have this, we can then import and like click this import button to import it as a collection. So I already have this API, so I'm going to click import as copy, but you should see something like it actually importing. So in my copy, I can click this dropdown, and I have all the same URLs as above. I'll give everyone like 30 seconds to get there. Where do we go to download the collection? You can go to that URL I just sent above, Trevor, for the hack Discord. I sent it in one of our channels as like a file. So if you visit that URL, if you're in the hack Discord, it'll link to this message right here. So you can click this button right here to download that. I believe I can upload it to Zoom as well. So I can do that as well if people are not there. Yeah, it's in workshops. Cool. I think I just sent it in Zoom as well. Cool. And then again, to import, it's file, import, upload files, upload that file, hit enter. Cool, cool, cool. Okay, so once we have that imported, let's go to the create auction Postman request. So here, you can see that we have a JSON that we're sending in our API request, and we expect something to happen in our response, right? So in our API request, what we're going to allow is an auction field that defines the auctioneer, like the person who's creating the auction, the name of the auction, so in this case, ACM Patagonia jacket, the description, which is, I guess, like any description. It's not on the store. Maybe it will be in the future. A start time, and this format is in JavaScript's format, so you don't need to worry about actually like editing this date. But this is how JavaScript formats dates. An end time, a starting price, and a minute increment, like we kind of showed in our type. You can see here that there's no ID field, which is why it was optional. So to actually implement this route, what we can do is go back to our code, and when we send this request, it should take the auction data, right? And then actually add it to our database. That's what we need to do, right? So if we go back to our code, what we can do is type in const auction equals, we can actually type it, right? Type it as auction equals request dot body dot auction. So you won't see type completion here. You can see it's of type any here. That's because like we can't actually like edit the type of body. But here, this is how we actually get this exact field that we see here, this exact object we see here. You can see like it's the request object that's passed in. We can look at its body and then get the auction. And we can actually just console.log this to make sure that that it's actually returning. So I'm just gonna have a console.log and have res.status 200 JSON like success true. You don't need to type this out right now. I'm just gonna to demo. You can see it is restarting and showing on port 2000. If I send that, you can see that there's a success true. And then here you can see it's printed exactly here. Cool. So then what we need to do is create an ID for that auction, right? So we can do what we could do is do const ID equals uuid dot v4. So this is going to create a uuid that's called version 4. This is not like something super important to know, but this is just how we generate uuids. And a uuid is like this is an example, right? This 249 thing. Right, then after creating our ID, we need to set the auctions ID field equal to ID. And lastly, we need to auctions dot set ID auction ID, or auction, not auction. So what's happening here is we create the ID, set auction.id equal to ID, and then add it to our map. And then lastly, what we can do is actually just send back the auction in our JSON, just to confirm that the auction has actually been created. So when we go back to our code and once it restarts our terminal, we can run this. And you can see here we have our exact auction, but with a different ID, or with like an ID field. And then if we go to get all auctions, and we hit send, you can see here, now we actually have the auction show up here. Oops. Any questions on that route? What happens if the rec.body's keys does not match the keys in auction? Great question. That'll lead to a lot of bugs in our code if the keys don't match. So let's say I do const auction equals rec.body.hello. Then auction is actually going to be undefined. So let's say I like type in console.log auction. If we don't send a object that's the type hello of that's like keyed as hello, right, is keyed as auction here, you can see there's a whole error that throws, right? We can go back to the code. Cannot set property ID of undefined. That's because auction's undefined. So for this workshop, we're not going to deal too much with validation. Like there's a whole field of backend validation where you basically make sure that the auction request, what's sent is the auction field, like it's called auction and not something else. And it actually has every field. For the sake of time, we're not going to be going over that. But in real backends, like for the portal, like membership portals backend, we definitely do that. Good question. Cool, so we can remove this. One last thing we actually need to do for this route, there's actually a sneaky thing that we do need to do, and you can see in types, we actually have start and end date as date types. But in our controller, or what we pass in, everything is typed as a string. You can see it's in quotes, right? So we actually need to convert the strings to a date. It didn't throw an error because TypeScript is not too strict about it. Like Java would probably throw an error, but TypeScript just naturally isn't that strict, like isn't as strict as Java with types. But one thing we do need to do is actually set the date. And how that works is we could do auction.start equals new date of auction.start. So this basically converts start to a date. And the new date constructor takes in a value as a string of like the current date. And we could do auction.end equals new date. That'll be all for the post route. Okay, let's go to the user route. We can implement this a lot faster because it's going to be very similar to this route. You can see in our create user route, we just have a user with a username and balance. What we can just do is do const user user equals rec.body.user, and then we can generate an ID in the same way. User.id equals ID, users.set ID, and then res.status 200.json. Cool, so very same thing as auctions. We don't need to do the whole date conversion, but now if we run this route, you can see we just created a new user with its own ID. And you could change this value to anything you want, but that's just my username. Alrighty, any questions on those routes before we have you all implement this route? And I'll go over exactly how we can implement this route. Like, I'll give some hints. Cool. Let's head back to the presentation. And let's hop over to our exercise. So for our coding exercise, we're going to implement placing bids. So what this route should do, it should do a bunch of minimal validation, right? So in other routes, we didn't need to do validation because like we wouldn't really worry about validation because like we're assuming all the fields that should be sent are present. But here we need to worry about if the auction actually exists and if the user has enough credits to make the purchase or make the bid, or if the auction hasn't ended, or if the user exists. Those are all things we should actually start worrying about. So that being said, we're gonna have these requirements for the code for that route. So what we're gonna do is, I have it in comments all here, but we're gonna implement these step by step, or we're gonna have you guys implement these step by step. So for some hints, just to quickly go over them, when we do all these validations, if you need to get the current time in JavaScript, for example, to check if the event or if the auction has already ended, you can do so like that. You can also use these comparators to get compare times. If you see, we've been using const as well a lot. If you need to reassign variables, you can use let, right? Because with const, you actually can't reassign auction. Like you can't say const auction equals this and then auction equals something else. That'll throw an error. So you can use let instead of const. And then lastly, to check the validity of an object, right? So say like, does an auction exist? You can use true false values. Like here's an example. Cool. So again, to really quickly walk through the steps, first we're going to check if the auction ID is valid. So again, like remember how in the past we've been looking at auction IDs, we use rec.params. You can use a very similar tactic here. We could check if an auction hasn't ended by checking its start and end times. If the user ID is valid, similar to this step. If the user ID has enough balance, that's going to be some logic we need to get the bid, get the user, etc. We need to check if the bid amount is high enough, update our database, return a successful response. So to test if your code actually works, if you're on Postman on this collection, you'll first need to make sure you create an auction, right? So create an auction, and then create a user, and then in our bid route, this is the data we're going to send. So you can expect the data to take this form. And you can see here, these fields will have the exact auction that you already created and the user that you already created, so that it'll use those data. If ever you need to update your code, this will restart the server. And since we're not actually using a database, these maps will all erase. So all your data will be gone every time, except the auctioneer data. So you're going to have to create an auction, create a user every time, and then you can run place bid. Once this route succeeds, then you know you've gotten the basic implementation down. Also make sure that these two routes fail, so that if you place a bid that's too low, like AKA it's the 10 versus 10.1, then that should fail. as well as if you don't have enough money to make the purchase, that should also fail. So once these three are success, fail, fail, then you can consider this like we finished the assignment, essentially. Cool. So what we're going to do now is we're going to take 20 minutes, so until the end of the workshop, to work on this. And what we're going to do is me and Ryan are going to hop on the Hack Discord voice channels if anyone has questions. So if you're on the Hack Discord, I can show you right here. So what we can do is if I'm on the Hack Discord, I can go down here and enter one of these voice channels. So I can hop in here. And now I'm in the Discord channel. If people need to ask us questions, you could just join the rooms that we're in and we can answer your questions. But yeah, what I'm going to do now is I'll turn on some music, and if people need to go, feel free. But like now we'll just take some time to implement that API route. So let me hide this. I'll turn on. It looks like we have 2 other people here live, so I'll actually do 15 minutes because I don't think take up the whole time. Let me test that. And then yeah, if you guys or need any help, like you can ask in chat or like join us in Zoom or in Discord or anything. Oh, yeah, we could probably just use Zoom, honestly. Yeah, if you guys, I guess like let me stop for a quick something. I can, because well, we're gonna take some time real quick to. All right, so now we'll go over the solution to the problem. I want to quickly add here, if we can actually add another type to the auction that I like forgot initially. So that's my bad. We can actually add a current bid field so that we could store the current maximum bid for our auction. So we can kind of rename this field to starting price and have this as current bid, or we could keep this as starting bid. I just didn't want to confuse starting bid as a number versus current bid as a bid. But yeah, these fields will help us in actually working with all these validations. So I'm going to do that and then quickly rename, or this is already starting price. I had it correct on here, but not on there. Oops. So yeah, let's go to controllers.ts and start implementing one by one. So first, checking if the auction ID is valid. We can use something very similar to up here, where we get the ID and then just check if it's valid, like check if it exists. So we could do is like const auction ID equals rec.params.id, and then const auction equals auctions.get auction ID. And then if not auction, right? So if the auction doesn't exist, we can do the same responses here, except instead of using ID, we use auction ID. Okay, so that's step one, checking if the auction ID is valid. Basically just checking if it exists in our database. Then we have to check if it is ongoing, right? So if it hasn't ended. So how do we check if it's ongoing? Well, we can use the hint in our slides right here. You can actually get the current time using new date. So we can just check if the current time is in between the start and end times. So what we could do is const now equals new date, and then say, okay, const is ongoing equals, let's say it's now, right? So now has to be greater than equal to auction dot start, and now has to be less than or equal to auction dot end, right? So now we have this Boolean, right? So then we say, okay, if it's not ongoing, then we can throw a 400 error. So 400 error is bad request. So if someone's trying to place a bid on an auction that doesn't exist, that's a bad request. So we could say something like auction of auction ID is not currently. Right. Cool. So that should check if the auction hasn't ended. Third, let's check if the user ID is valid. So we can have const of first, let's get the bid, right? Because if remember in Postman we have the bidder is the user ID, so we have to get the bid first and then get the amount in bidder. So const bid as bid equals rec.body.bid. Remember, because that's how we did it up here, rec.body.auction. Then what we can do is const, right, get the bidder ID as bid.bidder, and then const bidder equals users.get bidder ID, and then if not bidder, we could say user of bidder ID. That's step 3. For step 4, what we can do is check if the user has enough balance to place his bid. So this one is going to be one of the trickier ones. What we need to do is basically say, or actually this one's not that tricky. This is just if the bid amount is higher than what the user has, then we throw an error. So if bidder.balance is less than bid.amount, then res.status 400.json error. We could say user of bidder.username, because now we actually have the username, we could just display the username instead. Cannot afford this bid. Something like that. This is a quicker check. This one is the trickier one. Basically, we need to check if the bid is at least as high as the min increment plus the highest bid so far, right? Like you have to make sure it's high enough to place. So what we can do is we have to check the current bid and the min increment from the auction, right? Because if we look at auction, we have the current bid and the min increment. So we have to calculate it based on that. So we can do const current bid min increment equals auction. This is like shorthand syntax that I explained up here. With const ID equals rec params, we could do const current bid min increment equals auction. And then what we could do is that, okay, let's create a variable called minimum bid, which tells, okay, this bid should be the minimum highest, like the minimum bid price that you can do, right? So there's 2 edge cases that we have to think of that I think Trevor brought up earlier too, is like, let's say no one has a bid on the item right now, right? So there is no current bid, that's null. So if there's no current bid, then the next bid you can place is starting price plus min increment, right? So if not current bid, then the minimum bid is equal to, I guess, the auction dot starting price plus min increment, right? Otherwise, if there is a bid already on the item, then we have minimum bid equals auction, or is equal to current bid dot value dot amount plus min increment, right? And then what we just need to check is if the bid amount is less than the minimum bid, then we throw some error. That's the logic for getting the bid is high enough. So we could do here is we could do is the user, I guess we could say like bid amount must be higher than And then lastly, there's two more steps. What we just need to do is update our database. So we need to add the bid to our database and then update the auctions bid, right? So what we could do is say auction.current bid equals bid, right? And then the bid.auction equals auction.id, right? So remember here, we reference the bid auction to here. So we set the bid's auction ID, then we can actually update the auction, right? So auctions.set auction ID of auction. So what this does is it basically updates the auction in the database. So it's the same ID, but different object. And the object's one field that changed is the current bid field. And then what we can do, so I can group this under the same thing. And then what also we can do is now we need our bid ID, right? So uuid.v4. So this is similar to what we did here, right? And then we're just going to do the same thing what we did here. So bid ID dot, or sorry, bid dot ID equals bid ID. And then finally we could do bids dot set bid ID bid. So update the auction, update the bid. I guess we can group this. Lastly, we can just return res.status of 400.json. And we just return the bid, right? We just return the bid, and if it's successfully returned, then we're good. One thing I do need to note is we actually want to add return statements to our res.status so that, let's say, like in this case, right, if we have this auction and it's not there, and then this runs, but the function actually isn't returned, then the code will keep executing. And then it'll like return, and then it'll throw more errors. So we actually want to return all up here. We didn't need to return over here because these all is usually ended, like they're all one branch, but here we should be returning everything. So that's one last thing we need to add. And then there. And this is going to be status 200. One more quick JavaScript tip before we test is if you have syntax like this where both the key and the value are the same, you could actually just write bid here and it'll return the same thing. That's going to be all for this route. So what we could do is actually test this route. So here, let me create an auction. Let me create a user. Right, so I have the user, and then now let me use the user ID that I just created, an auction I just created to place a bid. So here I've just placed a bid on 200 as the starting price was 100 and my user had 200 balance. Let's say I want to place a bid of 50. You can see here I get bid amount must be higher than 220, right? Because the mid increment is 20, now the bid's 200, so it has to be 220. And also, if I try to place a bid of 250, I cannot afford the bid, right? So that's the route that we just implemented. Cool. Any questions on that? Okay, cool. I have a few more slides left. We'll make this super quick. It's just last couple notes on scalability for APIs. So I can share my screen real quick here or share the presentation. So on our API we just had, it runs locally on our computer, right, with localhost 3000, and we're sending like a few requests per minute. But if we go back to the Twitter example, like how do APIs like that are used in the industry? Because if you think about it, those APIs are getting like hundreds of thousands of requests per second, right? Well, here's an example. Robinhood, during the GameStop stock crisis thing, they were getting over 750,000 requests per second for their APIs during GME, right? Uber gets 4 million rides a day, which, think about how many requests that is. Like getting requests for a car, like the map changing, like delivering the person, like all that kind of stuff. And then Google gets about 5 to 6 billion searches per day, which is about 60,000 per second. Like, how do we make APIs that are able to handle that kind of load? Because right now, like, our computer is running our APIs. So if we get this type of load, our computer would immediately crash because the hardware is just not good enough to handle this much load. So one example we can do actually is something called vertical scaling. And all that means is just getting better hardware. So if our hardware right now can't handle that many requests, we can simply just get better hardware, and that could theoretically solve the problem, right? So like one example of this is if we have our API hosted on something like AWS, you can actually customize what hardware you have on AWS. So if you just like increase the hardware, like the specs on your server on AWS, or you just outright buy a new computer, then that could theoretically increase the request per second load, and that is an example of vertical scaling. Another thing we have is something called horizontal scaling, which means you have more computers that can handle requests. So that way you don't have, like, what would happen is you would have, instead of one request being sent to one computer, you can have requests being sent to different computers to handle the load. So how does that actually work? Like here you can see an example, like Google has millions of servers to handle the load. Like, are there just a million API routes that exist that Google has? Or is it all like one API route that just delegates to different servers? It turns out it's actually the latter, using something called load balancing. So with load balancing, a load balancer is a system or like a server that runs that basically delegates requests to different servers. So if you have like one server that had a bunch of requests sent to it, you wouldn't send it to that server, you'd send it to something else. There's different delegation algorithms that exist, like round robin. So that just means like you go in a line in the servers, like you go around and like, let's say I have 3 computers, I'll hit computer A first, then computer B, then computer C. And that's kind of how that works. So this kind of allows like horizontal scaling to happen because we can have multiple servers that all get requests from a client, right? They can get it from a client. Any questions on those topics? Cool. Yeah, that is all for the workshop. I know that was very long for those of you who came in person or like came live. But yeah, thanks for coming. For next week, we're during week 6, we're going to be having a database workshop where we are going to cover SQL concepts. And then we're going to be implementing databases in our application. So actually like creating database tables and all that kind of stuff for storing auctions, storing bids, storing users, that kind of stuff. So we'll dive into that. But yeah, I'm going to stop the recording now. So if you're watching this on the recording, thanks for watching.